In my last video, I explained how you can find the stress and the strain for a solid object under tension or compression. In this video, I want to show you how you can do the same for an object experiencing shear forces. But what exactly is shear force? Picture a block that's fixed to a table with a horizontal force present across the top face of that block. Because the block is fixed to the table will exert a horizontal force in the opposite direction on the bottom face of the block. In my last video, I showed how you could calculate the elongation for an object under tension or compression, knowing Young's modulus, the applied force, the cross-sectional area, and the initial length. For an object under tension, we know that the elongation will be positive, while for an object under compression, the elongation will be negative. We can actually use a similar formula to calculate elongation when shear force is present. In this case, instead of Young's modulus, a quantity known as the shear modulus is used. This value is usually smaller than Young's modulus and can similarly be looked up in a reference table. In this formula, A represents the area of the surface parallel to the applied force. So this is just simply the area of the top face of the block. And in this formula, the initial length is actually the height of the block. When the shear force is applied, this block will actually be distorted into the following shape. The elongation that we're finding is actually perpendicular to the initial length and is just the amount that the top left or right edge of the block shifts horizontally. Shear stress can be calculated by dividing the applied shear force by the area and is represented by the Greek letter tau. Notice how this is really just the same formula as tensile or compressive stress. Similarly, the shear strain represented by gamma is just the elongation divided by the initial length. The shear modulus is then just the shear stress divided by the shear strain. I hope that this video was helpful in explaining what shear forces are and how you can calculate shear stress and strain. These formulas are really just the same as the ones used for tensile and compressive forces. All you need to know is which quantities the variables represent. In my next video, I'll go over an example problem that combines these three types of forces and shows how these formulas can be applied. If you still have any questions, feel free to comment below and I'll do my best to answer them. If you found this video helpful, please give it a like and consider subscribing to the channel for more fast physics videos. Thanks for watching.